Hi everyone. In this video, I am going to discuss about evaluation of crude drug, second category, that is second evaluation, microscopical evaluation. So in last video, I have discussed about organoleptic evaluation of crude drugs. So in this video, we are going to discuss about microscopical evaluation of crude drug. So in this study, we can divide this microscopical evaluation into three types, that is histological evaluation, histochemical evaluation, and histological measurements. In case of histological studies, we have transfer section and powder microscopy of crude drugs. So for this transfer section or powder microscopy, we need three reagents, that is clearing agent, that is example for clearing agent is chloral hydrate or lactophenol, lactochloral, potassium hydroxide solution, mainly using for to clear the unwanted impurities or any cell debris, etc. So staining agent means name itself showing that to give the color of to the cells like fluorobutanol and hydrochloric acid for lignin, it lignified cells shows pink color. Then third reagent is mounting reagent to fix the cell into the slides, that is glycerin or glycerin water mixture we can use. So that's all about the histological studies. Next is histochemical studies, means chemicals present in the cell structures like cellulose, lignin, mucilage, fats, calcium oxalate crystals we can identify. In case of mucilage, with ruthenium red, it will show pink color, and starch we can identify using iodine solution, it will shows blue color. Then histological measurements means we can calculate or quantify the amounts like leaf constants, fiber length, width, calcium oxalate crystals, etc., starch grains, etc. So coming to the quantitative microscopy, we can divide this quantitative microscopy into 6 types. That too, leaf constant 5 plus 1 Lycopodium score method. So we can divide this leaf constant into stomatal number, stomatal index, vein islet number, vein termination number, and palisade ratio. And one more, Lycopodium score as quantitative microscopy. So before that, there are different characters present in the leaf structure. One is trichome. This is also known as plant hairs, mainly for the protection, or these are the elongated tubular outgrowth of an epidermal cells. It is present in other parts, or mostly it is present in leaves. Also it is present in bark, seeds, stem, etc. Main function is protection, secretion, then absorption or secretion of water, etc. So this is one of the structure of picturization of trichomes. So coming to the classification of trichomes, we can divide these trichomes into 3 types: covering or non-glandular trichomes, glandular trichomes, and hydathodes or special types of trichomes. Then special types, example fiber beetle, London pride, etc. Covering trichome we can divide into 2 types: unicellular and multicellular. Unicellular example is senna, cannabis, Microscopic, etc. Then multicellular again divided into unbranched and branched. Unbranched again divided into uniseriate, biseriate based on series. Then multiseriate. Uniseriate means one series, it occurs as one series. Example Vasaka. Then biseriate occurs as 2 series, that is calendula. Then multiseriate, male form. Then branched is stellate Hamelis, peltate croton. Then candelabra verbascum tapsis. Then T-shaped is example is trirethrum. Then glandular trichomes example unicellular and multicellular divided. Then unicellular example is Vasaka, multicellular example is digitalis and belladonna. So this is the example for covering trichomes. Next formica seed, it is lignified unicellular covering trichomes. In case of senna, it is short, thick, unicellular, slightly curved covering trichomes. Then these are the multicellular unbranched type: Osaka uniseriate, biseriate, marigold or calendula. Then multiseriate, male form leaf. Then typical covering trichomes like stellate trichome, Hamelis, then peltate croton, then candelabra as a hair, T-shaped trichomes. This is the example for glandular trichomes. There is globular head and stalk is there. Osaka sessile quadricellular heads. Then in case of digitalis, unicellular stalk with unicellular bicellular head. Then belladonna unicellular stalk with 2 to cell glandular head. Then that's all about trichomes. Second portion is stomata. Stomata means it contains two kidney-shaped cells that is known as guard cells, and it is covered with subsidiary cells or epidermal cells and having some central pore known as stoma. The main function of the stomata is gaseous exchange or helps in transpiration. So this is a picture. Mostly it is present in leaf, that is upper part and lower part. So most of the cases lower part contain more number of stomata. So coming to the classification of stomata, we can divide into parasitic, diacytic, anisocytic, anomocytic and actinocytic. In case of parasitic stomata, the two subsidiary cells is parallel to that of stomata. That's known as parallel parasitic, parallelly arranged. Example, senna and mocha. Then diacytic, diagonally arranged. The two subsidiary cells are diagonally arranged to that stoma. Example, peppermint, vasaka, etc. Then anisocytic means three subsidiary cells are present. One is smaller than other two. Example is datura, belladonna, etc. Then anomocytic stomata means number of stomata, varying number of epidermal cells are present. Example is digitalis or lobelia. Then actinocytic means subsidiary cells are arranged radially arranged. Example is sprang. So coming to the quantitative microscopy, we can divide into 6 types: stomatal number, stomatal index, vein islet number, vein termination number, palisade ratio, and lycopodium spore method. So this is the camera user equipment used to detect this leaf constants. It contains attachment ring, prism, and mirror. So we can draw the exact microscopic image through this microscope and by using camera lucida. And these images are formed on the microscope in the eyepiece. It is reflected on the paper by using prism and the reflecting mirror. And this attachment ring is attached to the camera lucida on the body tube around the eyepiece. So this is the diagram of camera lucida. So the light from the drawing paper and pencil is reflected by the light right hand mirror present in the right side of the mirror, the mirror of that camera lucida. By using white pencil and black paper, we can draw the exact images present in the eyepiece. That pencil appears superimposed on the object which can be traced. So this is the picture of a mirror, that is camera lucida with microscope and black chart, how they're drawing. Then coming to the quantitative microscopy, first one is leaf number, stomatal number. Then it is divided as the average number of stomata per square millimeter of epidermis of the leaf. So there are different types of leaf present. So we can count the stomatal number. So these are the lower surface stomatal number of Atropa, belladonna, acacia angustifolia, and datura stromonia. Stomatal index means percentage which number of stomata forms to the total number of epidermal cells. An equation is the number of stomata divided by number of epidermal cells plus number of stomata into 100. It's also Atropa, belladonna, acacia angustifolia, digitalis, copioria, datura stromonia I have included here. So these are the values for stomatal index in the lower surface. So coming to the procedure, first we have to clear the leaf fragments and we have to boil with chloral hydrate solution, and we have to peel out the upper and lower epidermis, and we have to prepare the mount using glycerin and water. And first you have to draw the square in a black chart and by means of stage micrometer and the camera lucida, and replace this stage micrometer after drawing that square, and we have to replace this stage micrometer with that leaf preparation, mounting preparation, and then start drawing that, trace the epidermal cells and stomata by looking through this microscope. By we can see the superimposed image of the leaf at the same time, and we can count the number of epidermal cells, also the stomata within that square. So we can, by using calculation, that is S by E plus S into 100, we will get the stomatal index. So this is how, just a drawing of how they will get that in a square stomata and epidermal cells, presence of epidermal cells. Third one is vein islet number. It is the average number of vein islets per square millimeter of the leaf surface midway between the midrib and margin. This is how through microscope that midrib we can see. There are different types of leaves like Asian rustifolia. Vein islet number is 19, in between 19 to 23. There are different plants like digitalis purpura, digitalis luteum. So this is how we get, after completion of that experiment, we get that vein islet number and vein termination number. The termination means it stops, it won't go further production, that is, it stops, that is not vein termination number. So next is vein termination number, number of vein islet termination per square millimeter of the leaf surface. So there are different types of plants and its vein termination numbers. So this is how the vein termination number occurs. So procedure means we have to boil the leaves with any clearing agent like chlorohydrate or potassium hydroxide solution. Then we have to mount in using glycerin and water. Then with the camera lucida, we have to divide the paper in a square. Then replace that stage micrometer with that mounting things in slide. Then we have to trace the veins in a 4 continuous square. Then vein islets also we have to trace. Then count the number of vein islet and vein termination number within the square. It can calculate and we can record that mean values. Then fifth one is palisade ratio, which is the average number of palisade cells beneath one epidermal cells. So this also we can calculate by using camera lucida. There are different types of leaves and they're having palisade ratio. So this is how 4 continuous epidermal cells we have to count under the beneath the that each epidermal cells we have to count the palisade cells also. So first we have to clear the leaf by boiling and camera lucida, by using camera lucida we have to draw the square in a black chart. Then trace the we have to replace the stage micrometer with mount and trace the 4 cells of epidermis, continuous 4 cells of epidermis, and we can count the palisades layers and the average number of palisade cells we can calculate. So sixth one is Lycopodium spore method. This is quantitative microscopy. That Lycopodium spore is, it's a dust-like, yellow dust-like things, powders having dry spores obtained from Lycopodium clavatum. That is Lycopodiaceae family, and it is having size to 25 micron meter and having uniform moisture content, weight, characteristic shape and appearance. Then 1 mg of Lycopodium spore powder contain average 94,000 spores. So we can evaluate different fibers, trichomes, etc., starch grains, pollen grains, etc., by counting, by using these spores. So this is how we have to do the procedure. Like first we have to air dried powders and drug and Lycopodium spore we have to mix. That is the concentration, that is 100 mg of drug means 50 mg of Lycopodium spore, 2:1 ratio in a glass plate where you're making smooth paste using any oil or suspending agent. Then place a drop on slide and put the cover slip and count the characters like starch grains or trichomes, anything we can count. So 4 set we have to count into 25 fields, that is 100 fields we have to count. So 1 mg of powder we can take. So we can calculate the number of characteristic particles present in this 1 mg of powder dried at 105 degrees Celsius. So this is the calculation used for calculating the foreign organic matters, like 94,000 into 100 into n into w divided by s into m into p. W is equal to weight in mg of lycopodium spore, n equal to number of particles in 25 fields, m equal to weight in mg sample. We can choose any ginger powder or something like that. So we can count within ginger, we can count any starch grains. Then P is the number of particles per mg of pure foreign matters, that is constant. In case of ginger, it is 286,000. S is the number of spores in the field of 25. Then 94,000 means number of spores in 1 mg of 1 milligram of lycopodium spore. So this is the picturization of lycopodium spore through the microscope and also the powder. Thank you.